there's very, very little wear. So the way that carbide dulls is it flakes. So the bigger the carbide, the bigger the chunks that are coming off. So ours is so small that even if some of the chunks come off, you can't tell. It's still going to give you a good smooth cut. And when you go take it back to the sharpener, he may only have to do one pass on each face, rather than if you're taking someone else's blade, he may have to, sometimes they won't even sharpen them because they won't guarantee you that you're going to get a good surface. And then you're taking so much off the tooth that it may throw the blade off balance. But to begin with, the blades are not balanced anyway. So really you're still back at square one. Okay? I was in the factory about 5 years ago when they refused the whole container load of carbide that came from one of the countries there because it wasn't ground to the specifications. And they random test different drums, and they test it and they put it down through an electron microscope, and if it doesn't meet the specs that they want, they'll send it back and the guy will have to reground it. And we get carbide from Austria, or the powders and the cobalt, Austria, Norway. We keep it within the European borders. We don't buy carbide from anybody else, not even from North America. No, these are all solid carbide.
Solid carbide.
Yeah. So the Rockwell steel on any blade that we have, regardless of the size, is a Rockwell. The Rockwell scale is what they measure the density of metal. Okay, the Rockwell scale on the blades is 46 on a laser cut blade, right? Hardness. On a stamp blade, let's say, lack of a better word, who should we use?
Yeah.
Skill?
Yeah.
Okay. On a skill blade, it's stamped. It's a Rockwell 25.
Mastercraft?
Yeah, it is ironic because we used to own Skill and we just sold it.
All right, let's try Mastercraft.
Yeah, well, okay. So it's a 25, so it's half. And then, so the carbide strength is a 98. So it's like off the charts. So that's why we can make blades that cut virtually anything, and I'll show you.
So that's why it can last for so long without sharpening.
Yeah. We did a test through years ago, and it'll stand its time today too. We took an $80 blade of ours, and we took an $80 blade of our competitors, the one that you can bring back and trade it in for a new one all the time. So every time this customer went and traded it in, both $80 blades, every time the customer went back and traded it in, we would send ours out for sharpening, regardless of whether it needed sharpening or not. So sharpening on an 80-tooth blade is about $20. So on an 80-tooth blade, the customer's paying $40 for the return. It used to be $40, now it's about $55. So guess what? After 5-6 sharpenings, it cost him $80 more for that blade. So you're no further ahead. So we're a solution-driven company because time is money for all of you, whether you're woodworkers, whether you're a construction guy. Time is money for everybody. You want something that works, it keeps working, and makes it easy for you to work. Yes, sir.
The blade that's being passed around, why is it called blue line?
So there's two blades. It's a glue line rip because you can rip down the center of a piece, and you can rip a series of pieces of wood down the center of a piece of wood. You can put them back together again, and I dare you to find where the cut line is. And you can't. That blade will not leave swirl marks in the wood. It's so heavy because it's a full kerf blade. There is a light version for the benchtop tools. We make both. So I brought the heavier one because that's something that you guys would use more than the light one. A lot of woodworkers are afraid of using the thin kerf blades because they think they flex, but they don't. We can take, this is the thinnest blade that you can buy.
How thin is that?
It's a .71.
So that's as thin as thing you get before it's unsafe to have something thinner?
No. It's just gotten thinner, but I can take this blade, I can plunge through 3-4 layers of shingles right through a roof, and I can take this blade and go this way, sideways. I can carve a bowl, it'll stay. It won't bend, it won't collapse. This is, again, as thin as it is, it's still a Rockwell 46 strength. Every blade we laser cut. We laser cut everything from 4 3/8 up to 30 inch. There is no such thing as a stamping machine in our building. You couldn't build a stamping machine foundation large enough to withstand the pounding that it would have to do to punch one of these up. And eventually that press will wear. On anything, it wears, right? The laser's constant. It's constant beat of light that's cutting all the time. No downtime, nothing. Any other questions?
Can we get into the curves, Luciano?
Yeah.
And just explain to everyone
Yeah.
the rationale and what that means and differences and stuff?
So this is the extreme thin curved blade. And this is construction. It's only built for the 7 1/4, 6 1/2, 5 3/8, 5 1/2. So from about 5 inch up to 7 1/4. Once you get into an 8 1/4 tooth, 9, it starts to get a little bit thicker. And then once you get to the 10 inch blades, and I'm sorry, but these things are all sealed. The tooth width on these ones are 3/32, where that one's a full 1/8. The plate is a 0.9 versus a 0.59, I think it is on that little 7 1/4. The reason that we build the thin curved blades is for underpowered machines. What did I see over there? The wall slide miter there. Those are underpowered machines. The deltas, the skill.
No underpowered.
No. What happens is, no. I mean, it will run a full curved body blade, but it puts a lot of pressure on the machine, on the motor. The motor's built at 15 amps, right? So that's 15 amp spindle speed. Who in here owns our Freud router? I think fellow in the back there. So we used to have a Freud router that was a 15 amp, but it was a true 15 amp. So it was not only spindle speed at 15 amps, but it was also with a load on it. So when you put one of these babies on, that's the biggest router that you can buy. Okay, when you put one of these on, and you can, with our machine, you can do this rail, right, in one pass. Because the motor gets constantly fed up to stay at that 15 amp all the time. It's a constant speed switch under load, yes. So unless the machines are built with an underload, with a load variator on it so that it can bring the load up as it needs it, they run at 15 amp. By the time you put a blade on it and you're cutting through wood, you're lucky if you get 12 out of it. Okay? So thus we built the TK blades, and it just satisfies everybody's needs. Now, the Diablo version is on the construction side, but there's some really neat. This blade here, it's got side grinds. You can cut. This is good for real wood, by the way. It says melamine, but you'll ruin it. Real wood, when you cut this, it gives you a finish of 1,000 grit sandpaper. Okay, so we took the technology off of these blades, and we're stepping it down to a consumable item. So this blade sells for $100. This blade sells for $400 or $500. So this blade will outlast everything. But you can get this same type of finish, but you have to pay probably 2-3 times the amount on an industrial blade.
That blade there, if you were running saw like that and you lost teeth off it,
You get them welded back
I would
on.
bring that back and have you weld them back on or
Yes.
whatever, right?
Yeah.
But that one, the cost isn't built into that.
No, the rule of thumb is that if you're paying more than $50 for a blade, then get it sharpened. If you're not,
Yeah.
we used to put on all the blades. Actually, there's one right here. It can get sharpened 6 times, and you can. These ones, you can sharpen 10 times, right? 11, 12, depending on the usage.
So when the guys are going into the stores to pick up these blades or any blade, typically the packaging will explain
What it can cut.
what it's cut for, right?
Yeah.
And there's very specific blades, tooth count
Yes.
that the guy should be aware of when they're buying.
Yeah. So, a 7 1/4 24 is cross-cutting, ripping, and it's primarily construction. So you go from a 24, then there's a 24 demolition blade, then there's a 40 tooth for fine finishing. This is a guy that's doing his own work in the house, and then there's a 60 tooth for extreme fine finishing. Then you start moving up to the 8 inch blades, both ripping and general purpose or finishing. So as you get to the large diameter blades, 10-inch blade, for instance, right? You get a 10-inch by 40. It's a general purpose blade. You can use it on a miter saw, a slide miter saw, or a table saw, right? And then there's a 50 tooth, which is a true combination. It's built with, I didn't bring one, but this is the 40 tooth. And you'll see, even on the blade that I was passing around, you see all these little anti-kickback shoulders. That's to stop the blade from binding and kicking. That's to stop the front tooth not cutting any more than the back tooth. That's what causes kickback. If you have a tooth that's off, that's not built properly, when the tooth comes around, it's taking out too much. The one in the front, the one in the back, and it's just boom, it kicks.
Luciano,
Yes.
can you show the camera when you're doing that?
Oh, sorry.
It's a great point. I just want to make sure we
So
can see it.
there's anti-kickback shoulders on every single one of these, and not all of them that we build them that way, but these little protrusions in the back, and basically all they do is stop the leading edge tooth from not cutting any more than the tooth in front of it. So it stops it from kicking. You get a lot of kickback on wet lumber. Thus, a lot of the 7 3/4 are extremely thin, and this will be used more for people that are doing decks and fences. And as we talked about before, you get a lot of wet lumber, and if you're ripping a deck board, you're going to get kickback. We don't want that to happen. All right, so we build them with anti-kickback on them. So before, these little, you've seen on the industrial blade that I was handing out, had what we call the harmonic balancing, or the balancers. They used to go from here all the way down to the center. On the large blades, they still do. On the industrial large blades, they still do. These ones here, because all the meat cutting is done here, we've put the balancers over here to keep the blade stiff and straight. And we fill it with an epoxy to keep sawdust from getting inside. So if the sawdust gets inside, it'll start to bang, right? It'll start to heat up. You don't want that. Then you are going to get a warp, or you'll get some kind of deflection.
You have a little curl every so many teeth underneath the blade too.
This is actually the heat expansion.
Okay.
The question mark? Duh, what am I doing there? Yeah, that's what everybody, and these are all laser cut as well. It's all done by different lasers. This is done I believe this is done just after the reannealing process. So you'll get it on that, but you see, you won't get it on the 90 tooth or on a 100 tooth blade. These are thin enough that you can put it on, but this is, okay, we're going to step back a little bit, okay? This 100 tooth blade has a positive 7-degree angle forward, right? This one here will have probably a positive 12-degree forward, okay? So, what does that mean? So the further the tooth is ahead of the center hole, the more aggressive the blade becomes. So you get a ripping blade, something like this, let's call it. You get a rip. This is a combination blade. This does equally as well, cross-cutting and ripping. But you get a ripping blade, like the glue line rip we had. That sits at about 23 degrees forward to center. So that's really aggressive. Okay. So when you're feeding it into the wood, you don't want a lot of teeth in there. How do you typically set up a blade when you're cutting a piece of 3/4 inch stock?
Just above the stock.
Gullets are just above the top of the
Yes,
stock.
just above.
The whole gullet's just above the stock?
Yeah,
Okay, so try it at about a half a tooth above the stock.
Yeah.
okay.
And on any blade, not just ours, on any blade on the marketplace, you could literally use a ripping blade to cut a piece of melamine chipless. So, half a tooth above the surface of the wood.
Because of the positive nature of the. Okay.
Yes, so what happens is,
Now, just with that blade, just with the combination? Or
any blade,
Any blade?
any blade.
Okay.
Any cross-cutting blade, any ripping
Any
blade.
blade cross-
Because when you're ripping, you don't want a lot of teeth inside the wood at a time. 1.5 to 2 max.
Okay.
All right. So if you bring it up a full, you may get another half a tooth in that wood that you don't really need.
Okay.
So ripping, you're going through the heart of the material. There's no resistance. When you're cross cutting, there's a little bit more resistance. So that's why they add teeth. So you get more teeth in the wood to do your work.
Yeah.
Thus, it cuts it faster. So with ripping, you pull it up, because when the tooth is up here, right, as it comes down, it slams the top of the wood. Perfect example is melamine. When you're cutting melamine, if you do a half a tooth, I've seen people put it up to the top, and they're complaining why the melamine is chipped at the bottom or chipped at the top, right? So the tooth is coming down, because the melamine is here, the tooth is coming down, and it's smashing it this way. Well, it just explodes the melamine, because the surface, as hard as it is, if it gets hit by a hammer, it'll crack, right? So this is what this is, it's a hammer. So if the tooth is down here, as the tooth comes off, it actually shears the melamine, or it shears the wood, so you're not getting that chip. So as it comes out the bottom, it's shearing the same thing. The higher you put